Hi, so this video will be about supercoiling. So let's get started. Supercoiling is when DNA becomes more compacted by coiling even more of the DNA. This can create less space and can take place when there is over-rotating or under-rotating, and it cannot be compensated for. Compensation for this would be done by the ends of the double helix, but if it is circular, this is harder because there are no free ends. A coiled or relaxed DNA would look like the circular DNA on the right, while a supercoiled DNA would look like the one on the left. We can see this structure in things that we use day to day, like headphones or when telephones had cords and they would get stuck together. There is negative supercoiling and positive supercoiling. Positive supercoiling is left-handed and over-rotated, while negative supercoiling is right-handed and under-rotated. Most of the DNA found in cells is negatively supercoiled, and because it is under-rotated, the separation of the two strands during replication is a faster process and requires less energy. Torsional stress occurs in the unwinding of DNA and will begin to build up ahead of the replication fork. This is due to unwinding and induces supercoiling by opening up the DNA. This is reduced due to topoisomerase. Topoisomerases are enzymes that can add or remove rotations from the DNA helix by breaking nucleotide strands. It does this by rotating the ends and then rejoining them. It can induce and relieve supercoiling. By relieving supercoiling, it makes sure that the DNA stays in the structure that would be better for transcription and replication. Topoisomerase 1 makes single-stranded breaks, and topoisomerase 2 creates double-stranded breaks. If topoisomerase did not relieve the supercoils, it could lead to problems in strand separation and therefore the replication process. This is important to replication because it makes sure that the DNA is in a more relaxed state ahead of the replication fork. A more relaxed state of the DNA makes it easier to start the replication process. If the DNA was free to rotate, this would lead to supercoiling and less relaxed state, and therefore using more energy. This would also impact processes like transcription and replication.